Hi all. Today we are going to study about inverse of a matrix. If A and B are two square matrices of same order and A into B equal to I in identity matrix, then B is inverse of A and A is inverse of B. That is A inverse equal to B. We did not like this, A raised to minus 1. We read it as A inverse equal to B and B inverse equal to A. For example, A equal to matrix 2, 3, 1, 2 and B equal to 2, negative 3, negative 1, 2. AB equal to matrix 2, 3, 1, 2 into matrix 2, negative 3, negative 1, 2. Then multiply it. Then we get first row into first column, that is 4 plus negative 3. First row second column, negative 6 plus 6. Second row into first column, 2 plus negative 2 and negative 3 plus 4. When we add it, we get 1, 0, 0, 1. That's equal to I. BA is equal to matrix 2, negative 3, negative 1, 2 into matrix 2, 3, 1, 2. Then column 4 plus negative 3, first row into second column, 6 plus negative 6. Then second row into first column of the second matrix, negative 2 plus 2 and negative 3 plus 4. That's equal to 1, 0, 0, 1. That's equal to I. So A is inverse of B, AB equal to I. Therefore A is inverse of B, that is B inverse equal to A, and B is inverse of A inverse equal to B. Then another result of inverse is AB whole inverse equal to B inverse A inverse. AB whole inverse equal to B inverse A inverse. Sometimes they ask to prove this. Without counter examples, we can prove it. That is the proof. We know that one result, A into A inverse equal to I. Therefore, AB into AB whole inverse equal to I. So this proof start from this step, AB into AB whole inverse, that is LHS equal to I. By this result, that implies we multiply both sides, pre-multiplying by A inverse. That is A inverse into AB whole inverse equal to A inverse I. Pre-multiplying both sides by A inverse. That implies A inverse A. We collect the A inverse A to one bracket into B into AB whole inverse equal to A inverse into I equal to A. So we can write it as, that implies IB, A inverse A equal to I. So I into B into AB whole inverse equal to A inverse. That implies I into B equal to B into AB whole inverse equal to A inverse. Then again pre-multiply both sides by B inverse. B inverse B into AB whole inverse equal to B inverse A inverse. Again B inverse B is I. B inverse B is I into AB whole inverse equal to B inverse A inverse. That implies I into AB whole inverse is AB whole inverse equal to B inverse A inverse. So this proof is very important. Another question is, let A equal to matrix 2, negative 1, 3, 4, B equal to 3, 2, 7, 4, C equal to 2, 5, 3, 8. Find a matrix D such that CD minus AB equal to 0. So A equal to 2, negative 1, 3, 4, B, 5, 2, 7, 4, C, matrix 2, 5, 3, 8 are of the same order, 2 by 2. We want to find out D. So let D equal to, we take let D equal to matrix ABCD. Then CD minus AB equal to 0 given. Then here we have substitute the values of C and D and A and B. So 2, 5, 3, 8 into ABCD minus 2, negative 1 A, matrix 2, negative 1, 3, 4 is A into B is 5, 2, 7, 4 equal to 0. That implies 2A, first row into first column, 2A plus 5C, first row into second column, 2B plus 5D, then second row into first column, 3A plus 8C, second row into second column, 3B plus 8D, minus, here also multiply, first row into first column, 10 plus negative 7, First row into second column, 4 plus negative 4. Second row into first column, 15 plus 28. First row into second column, 6 plus 16 equal to 0. Then 2a plus 5c, 2b plus 5d, 3a plus 8c, 3b plus 8d minus, can reduce this matrix, 10 plus 97, 3, 4 plus 94, 0, 15 plus 28, 43, 16 plus 6, 22 equal to 0. Then matrix 2a plus 5c, subtract these two matrices. Or we can do like this also. You can take this to right side. So 0 plus matrix 3, 0, 43, 22. Then you can equate it. 2a plus 5c equal to 0 plus 3. Here we subtract here. 2a plus 5c plus negative 3. 2b plus 5d plus 0. 3a plus 8c minus 43. 3b plus 8d minus 22 equal to 0, 0, 0, 0. So 2a plus 5c equal to 3. 2b plus 5d equal to 0. 3a plus 8c equal to 43. That means minus 43 equal to 0. 3b plus 8d minus 22 equal to 0. Solve 1 and 3. So from these four equations, we want to find out a, b, c, d. That is solve 1 and 3. 2a plus 5c equal to 3, equation number 1, and 3a plus 8c equal to 43, equation 3. Multiplying 1, equation 1 by 3, we get 6a plus 15c equals positive 9, equation number 5. Equation 3 into 2, that is 6a plus 16c equal to 86. Then 5 minus 6 gives 0, 15 minus 16, negative 1c equal to negative 77. Then c equal to 77. Put this value in 1, we get from 1 we get 2a plus 5 into 77 equal to 3. 2a plus 385 equal to 3. 2a equal to 3 minus 385, that is negative 382. So a equal to negative 382 divided by 2, which is equal to negative 191. Then solving 2 and 4, 2b plus 5d equal to 0, 3b plus 8d equal to 22. Equation 2 into 3, we get 6b plus 15d equal to 0. Equation number 6, and 4 into 2 gives 6b plus 16d equal to 44, equation number 7. Then subtracting 6 minus 7 gives negative 1d equal to negative 44. So d equal to negative 44 by negative 1, which is equal to 44. Then from 2b plus 5 into 44 equal to 0. That is 2b plus 220 equal to 0. So 2b equal to negative 220. b equal to negative 220 divided by 2, which is equal to negative 110. So d equal to matrix a, b, c, d equal to matrix negative 191, negative 110, 77 and 44. So if you understood this video, please click the like button and share this to your friends. Don't forget to subscribe it. Okay, thank you.